let's talk about some of the important vocabulary when it comes to polynomials so that we can start to talk about them with formal language. So just as a reminder, a polynomial is a mathematical expression that contains variables and coefficients that involves only addition or subtraction between terms. So addition or subtraction between terms. So just as a little reminder, right, coefficients would be the number in front of a variable. Oops, in front of a variable. So we're talking about any combination of variables and coefficients that are put together with addition or subtraction. So there are two ways to classify a polynomial, or basically two different kinds of names that we can give them. The first of those is classifying by the number of terms, or the number of pieces in the polynomial. So the first term that we can have is a monomial. The first name we could have is a monomial. And a monomial refers to a polynomial with one term. You might see that the word mono, or the root mono, one there, so one term. So an example could be something like 2x. Even though it's got a coefficient and a variable, there's nothing else being added or subtracted there. Another example could be simply 5, right? There's nothing else going on. A monomial could be even as complex as something like negative 41 x to the third y squared z to the fifth. So even though there's a lot of different variables and exponents and a coefficient in there, the fact that we're not adding or subtracting anything else means that this is all just one single term. It's all one term. The next one we could have is a binomial. And again, based on that root there, this is a polynomial with two terms. So something like 4 plus 5. That's not a binomial because 4 and 5 can be combined to make 9, right? Those are like terms. So this is not considered a binomial. A binomial has to be two terms that cannot be combined. So something like 5x plus 1. An x and a constant, those are not like terms. They cannot be combined, so this is a binomial. It could also be something like x squared plus x. Again, even though they both have x's, that exponent, the x squared, is different than the x, so they're not like terms. One more example here. How about something like 3x squared minus 5? So it doesn't matter what the coefficient or variable or exponent is, as long as there's two of them and they're not like terms, we call it a binomial. Another way to classify this, right, is if we have three terms, so a trinomial. And again, it doesn't really matter what the variables, coefficients, constants are, as long as they're not like terms, and there's three pieces. So like 2x squared plus 9x plus 5. None of those pieces are like terms. There's three pieces combined by addition or subtraction, just addition in this case though. We could also have something like x to the 8th minus 2x minus 3. So again, it doesn't really matter what variables exponents are, as long as there's three of them and they are not like terms. So classifying by number of terms. Now, obviously, we could have polynomials with more than just three terms, but for our sake, we're just going to call those polynomials. Or we could say something like a 4-term polynomial. The second way to classify a polynomial is something by the degree. So the degree of a polynomial refers to the largest exponent of the individual terms of a polynomial. So the highest exponent. So it doesn't matter what the coefficient is, we're looking for the highest exponent. Now, exponents can get pretty wild here, right? We can have lots of different exponents, but we're going to just focus on a few here to keep things straightforward for ourselves. So If our largest degree is 0, we call that a constant. Now, one way to remember this, if it's a degree 0, that means that there is no variable at all. Right? If we think of what variable means changing, and the opposite of changing is constant. So an example like 6, right? There's no variable there. If there was, it would be something like x to the 0th, right? But x to the 0th is just 1, which is 6. So that's what we call a degree 0. Some other examples would be -7 or 312. It doesn't matter what the value is, as long as there's not a variable, we call it a constant. Now, if we have degree 1, we call that a linear polynomial. And this is hopefully a pretty familiar kind of polynomial. An example could be something like 3x plus 5. Now remember, if we don't see an exponent there on a variable, right, we know that that's a ninja 1. So that's why we call it a degree 1 linear. So let's do one more example there, maybe negative x minus 4. Right? Again, it doesn't matter if the coefficients are positive, negative, large or small. It's based on the exponents there, the highest degree. Degree 2 is called a quadratic. So an example there might be x squared minus 3x plus 1. Or maybe negative 2x to, oops, hold on. Let's try 65x squared. So even though our coefficient is 65 here, right, we're only worried about that exponent. The largest exponent is 2, making it a quadratic. Just a couple more here, points of interest. If we have a highest degree of 3, we call that a cubic, right? Like power of 3 would be cubed. We call that a cubic function. So how about 5x to the third plus 2? Or even something a little bit more intense, like negative 2x to the third plus 6x squared minus 2x plus 1. So even though, for instance, in that second example, our largest coefficient is on the square term, we just don't care. All we care about is that highest exponent, which is 3. One more degree, or excuse me, degree term here. If we have a power of 4, we call that a quartic polynomial. So 8x to the 4th, or negative 3x to the 4th minus 5x plus 2. We can have higher degrees, right? We can have degree 5 or even degree 50. We're not going to worry about those right now. I just want to make sure that we have some of this basic vocabulary down. So again, 2 ways to classify polynomials or to give them names. One is by the number of terms, right? How many individual pieces there are that are combined by addition and subtraction, or classifying by degree, which would be the largest exponent in the polynomial. So thanks for checking in. Hang in there.